Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized, understandable chunks. Today, we're talking about the heart, specifically a really common but often missed heart problem, and a new AI that might just be the key to diagnosing it.
That's right. Imagine this. You go to the doctor with chest pain. They do the standard test, an angiogram, where they inject dye into your heart's arteries and take an X-ray video to look for blockages. The doctor comes back and says, "Good news, your main arteries are clear, but you still have chest pain. What's going on?"
For millions of people, especially women, the problem isn't in the big main arteries that we can see on an angiogram. It's in the tiniest vessels, the microvasculature, that branch off from them. This condition is called coronary microvascular dysfunction, or CMD. The big pipes are fine, but the small ones are failing to deliver enough blood to the heart muscle.
And this is a huge blind spot in cardiology. CMD is linked to a much higher risk of heart attack, heart failure, and even death. The problem is that the gold standard test to diagnose it is invasive. It involves threading a special wire deep inside your coronary arteries to measure flow directly. It's risky, expensive, and only available at specialized centers.
So millions of people are left without a clear diagnosis. But what if the answer was hiding in plain sight all along? That's the idea behind a new paper titled PUNCH, Physics-Informed Uncertainty-Aware Network for Coronary Hemodynamics.
That's a mouthful, so let's break it down. PUNCH is essentially a very clever AI framework. Its goal is to measure blood flow and diagnose CMD using only the standard angiogram videos that are already being done every day. No extra invasive wires needed.
The core idea is brilliantly simple. In an angiogram, a doctor injects a contrast dye. PUNCH treats this dye like a tracer. Think of it like dropping a rubber ducky into a river to see how fast the water is flowing. By watching how fast the blob of dye travels down the artery in the video, the AI can calculate the speed of the blood.
Right, but it's more sophisticated than just timing a rubber ducky. This is where the physics-informed part of the name comes in. This isn't just any AI that's been shown a million pictures. It's a neural network that has also been taught the fundamental laws of physics, specifically the equations of fluid dynamics that govern how liquids move.
So instead of just guessing, the AI is constrained by real-world physics. It takes the video of the dye moving, turns it into a map of movement over time, and then uses these physics equations to solve for the hidden variable it can't see directly, the blood flow velocity.
And it does this for two different states, the heart at rest and the heart under stress, when a drug is used to make it beat faster. It then calculates a crucial number called the coronary flow reserve, or CFR. This is basically the ratio of blood flow under stress compared to blood flow at rest. A healthy heart should be able to pump much more blood when needed. If it can't, the CFR score is low, and that's a strong sign of CMD.
But here's what I think is the coolest part of this whole paper, the uncertainty-aware piece. The PUNCH AI doesn't just spit out a single number for your CFR. It gives you a result with a confidence interval.
Which is so important in medicine. It's the difference between a weather app saying it will rain tomorrow and one that says there is a 90% chance of rain between 2 and 4 p.m. If the angiogram video is blurry or the patient moved, the AI will know the data is poor and say, okay, the CFR is probably around 1.8, but I'm not very confident. It could be 1.3 to 2.3.
Exactly. Doctors call this honest AI. If the video is crystal clear, the AI will come back with a very tight, confident range. This allows a doctor to make a much safer and more informed decision. A confident low score might lead to starting a new medication, while a very uncertain score might mean they need to repeat the imaging.
So the theory is great, but does it actually work? Well, the researchers tested it rigorously. First, they created 1,000 synthetic computer-generated angiogram videos where they knew the exact correct blood flow speed. They fed these to PUNCH, and it nailed the predictions. Crucially, when they added noise and artifacts to make the fake videos look messy, PUNCH's uncertainty levels went up appropriately. It knew when it was looking at bad data.
Then came the real-world test. They took 12 patients who had received both a standard angiogram and the invasive gold standard blood flow measurement. They let Punch analyze just the video from the angiogram and compared its results to the real measurements from the invasive wire.
And the results were remarkable. The correlation was incredibly strong, with a Pearson value of 0.90, which is very close to a perfect 1.0 match. Punch was able to accurately calculate the patient's coronary flow from the video alone. Even more impressively, the AI's results were often more consistent than the invasive measurements themselves, which can vary quite a bit each time you do them.
The implications here are huge. This could completely change how we diagnose heart disease. There are about 4 million angiograms performed every year in the US and Europe. The vast majority of those are just looking for big blockages.
With Punch, each one of those standard procedures could be instantly transformed into a sophisticated functional test for microvascular disease at no extra risk to the patient. The whole analysis takes about 3 minutes on a standard GPU. It democratizes the diagnosis, making it available everywhere, not just at a few elite hospitals.
It's a perfect example of unlocking life-saving information that's already there, hidden in our routine medical data. It's not about a fancy new scanner, it's about making the tools we already have infinitely smarter and more powerful.
And by giving doctors a tool that is not only accurate, but also honest about its own limitations, the Punch framework is paving the way for a safer, more trustworthy generation of AI in medicine.